长牙四足，破门而开，只见千须半步。一人曾去目，孤行伫立，待得日当正中。等脚问句残花乎？第一口难辨是非，唯有墨鱼之术。盘中人皆得正夜忽，耳鬓闻琴上风骨。胸车一寸，一方便言和，一对对正主。有下人无语，红纸飞鸟唯有一人卡夫。对月相连，和手指相互，都是在无心日出。横听手指点，那勾交接变化。笔奏老舍墨书，春秋尽潇洒。不见当秋千人并道，今舟上刻画。烟坠长万岁，千载人生花。聊一书笔写遍古今的繁华。出镜如变，故自将历史传达。你总千年悠悠，谁人能回答？一颗相信花香，对断烟点周沙。下出2天，大到一桌之间，榜诗半遍。人我横双眼，坐立周家独片残枝出檐。地上编着半生缘，观曾海底水无存，只剩半杯似剑。禁不住抗年无手住，下飞开日出期限。闭目静白，为我而立，平衡我山前，长街尽无睹。若是日下竟有狮子沉淀，地下开眼，草人不见，定舍绿雾中头衔。水陆玄真举墨藏风的正法，书功南北教授相传满天涯。可问谁人流上去，谁人听众喧哗？别知今朝报纸下有几家，且把残好书当年一起风发。看遍沧桑何惧岁月的冲刷，字字珠玑绕有几人能进化？正一书注一画，行万年而笔下。我自奏你成字画，何问何大众感官，知晓吗？哇 ！Good morning, good afternoon, good evening， 早上好，中午好，晚上好，我还有こんにちは、こんばんは。然后这个时候又到了 ，It's this time again. It's this time again, and we are going to do some programming. So, where do we end up? Well, how come this all finished? The point finished. The pointer is fast and slow. This is already done. Now we can go to the next one. Hello, Harm. Hello, Yeying. And someone else I missed. Hello, 方云。死，你这个名字不会念。Hello, Cole. Okay, happy numbers. This is a medium difficulty, and this is still under the pattern for fast and slow pointers. Any number will be called happy number if after repeated replacing it with a number equal to the sum of the square of all its digits, leading us to the number 1. All others not happy number will never reach number 1. Instead, they will be stuck in a cycle of numbers that does not include 1. Okay, after reading this, I have no idea what they talk about. Hello, Joel. Giving a positive number n, return true if it's happy number, otherwise return false. Input is 23. Output is true. 23 is a happy number. Explanation: there are steps to find out that 23 is a happy number. "23 is a happy number." Huh? Hello, Plane. Well, before fixing the problem, I have no idea what the problem is. Any number will be called happy number if after repeatedly replacing it with a number equal to the sum of the squares of all its digits leads us to the number 1. Replacing it with number equal to sum of the squares of all its digits. Sum of square of all its digits. Square of 2 is 4. Oh, okay. 23 square 2 is 4. 4 plus 9 is 13. Square of 1 plus 3 plus 9. Oh, this equal to 13. So you do the 13 again and then you square each digits. 1 plus 9 is 10. 10 is 1 square and 0 square. So 1 plus 0 is 1. So it ends up with 1. Oh. Oh, okay. Half is not a happy number because 1 square plus 2 square is 5. 5 square is 25. It's a single number. 2 square plus 5 square. Oh, we need to account for single number. It's not a happy number and it's gonna be infinitely start a cycle. And we can determine there's a cycle because we get a same number twice. Okay, so this is where fast and slow pointer is. Okay, now the problem is how do I break them down into two numbers? This is the numbers. I guess it's we can convert this number into a string, and then take the first character and take the second character and convert them back to integers, and that's we get 2 and 3 from 23. 像这哪些语言啊？JavaScript、PHP、SQL、CSS、HTML。所以这里考的不是那些前台的东西。Okay, that's one way to calculate whether there's number, but I can also do I can also take 23 mod 10, which is equal to 3, and then 23 divided by 10. Round it down, which is equal to 2. So if I do that, this number will be 23 mod 10. Which is 5, and then 23. So this will be 5 plus 0. Like 5 plus 0. So it's okay to be a single number, because eventually the second number will always be 0. Okay. So first thing you want to do is I'm gonna write a function to break the number down. Right, it doesn't matter which side, because it's a sum of these two values, so it doesn't matter 5 is first or A is first. So I'm gonna call it to num, and then we're gonna pass in a num. And then we are going to return the first one we want to is math floor of num divided by 10. And second number is num and mod 10. Right, so if I console log this right now, 2 nums, and passing in the num, I should get this 2 value. So run this. 23 I should get 2 and 3. So 2 and 3 here. And if I pass in like 5, I should get 0 and 5. 1, 0 and 5. Okay, so that's the first part taken care of. And now we need a, so let's slow equal to, we have a slow pointer, fast pointer. And we don't want the pointers to meet. Let slow equal to none and fast equal to none. While I want to say while they don't equal, but they're gonna be equal in the beginning. Constraint is that the number is greater than or equal to, so I'm gonna set one of them to 0. While slow is not equal to fast. Okay, the way we calculate this is well, first fast should also be number. Slow is equal to 2 nums of the slow number. Okay, let's do AB. A equal to 0, B equal to 0. AB is equal to 2 num and then implying slow. Hence we can update slow to A square. A times A plus B times D. And then fast will be C and D. And we can do two nums of fast. Fast is equal to C times definitely C times CB. I don't need to break this down. I can write everything the same thing. So let's AB equal to math floor. Actually, let A equal to floor and let B equal to mod. Return A as A plus B times B. So we don't need to do this whole thing over and over. So slow equal to 2 num slow, and fast will equal to 2 num of fast. So we're doing 2 num and 2 num. 2 num of 2 num. Fast. So this fast should be also equal to num. Right, eventually slow will hit if slow is equal to 1, then we found the happy number, so we just return true. Okay, the first thing is like this condition will not meet because these two initialize will be equal. So what we need to do is that I believe in JavaScript do and then while. Yeah, so we're gonna do this. We're gonna do this one time. And then while they are not equal. So if I run this, both. This is JavaScript. Okay, so what we're doing is that we initialize the slow pointer to be the num, and fast one pointer also be the num. So we're gonna do this. Yeah, if we begin the num with 1, then this should return true. So slow is equal to 2 nums and passing the num. Initially the num is 23, right? So num is 23, math float num my stand. This A is 2 and this is 3. So B is 3. So A 2 times 2 is 4 plus B 2 times 2 is 4. 9. 9 plus 4, which is this one, is 13. And then fast is, since this value is the same, so fast is 2 nums plus 13. 2 nums 13. 13 will be math floods 1. 13 minus 10, which is 1. So A would be 1. And then 13 mod 10 would be 3. So B should be 3. 1 and 3. So 1 times 1, 3 times 3. This should return 10. So fast should now be 10. So fast should be 10. And because these two are not equal, so we're gonna run this again. Slow will be now be 10. And then fast will be 2 num fast. 10. Divided by 10 is 1. Flood would be 1. 10 mod 10 is 0. So this plus this should be 1. Fast now should be 1. You know, 1, and then you this the first 2 num will be 1. And then the second 2 num of 1. So 1 divided by 10, flood is 0. And 1 mod 10 is 1. So this should still be 1, because 0 plus 1 is 1. So fast will not be forever 1. And now, since slow is 10, fast is 1, they're not equal, we're gonna run this again. And slow will be 2 num of 10. So math floods 10 minus 10 is 1, and then 10 mod 10 is 0. So this should be 1 now. Slow will be 1, and then because slow is now 1. Slow is 1, but then they're now equals. They are now both equal. Okay, what about slow is equal to 1 or fast is equal to 1? Then we return true. Run. Okay, true. We have got this. Submit. There's an infinite loop somewhere. Probably not always 2 number, yeah. I discussed that earlier. In fact, one of the examples they give is that after 1 plus 2, 1 square plus 2 square is equal to 5. That's not 2 numbers anymore. However, what we want is the sum of these 2 values. So we don't care about it's 5. So in my calculation, it will be 5 square plus 0 square. So it will still be 25. So we don't care about it's 1 number or not. So in these calculations, just one of them will become 0. This is 什么？这是编程。Time limit exceeded. Use example test case and run this. This will only mean that They cannot get out of this while loop. So one of these cannot get out of while loop. If I use test case 1 and then run this. Okay, true. And the other test case was 12. And run this. Okay, 12 is this one, and it gives me an infinite loop. So what we're gonna do is that we can look at the outputs here. Right, so before returning this output, we're gonna console log. We're gonna console log this value, and they should be equal to these values. I'm gonna run this. Run it for little bits. And then I'm gonna cancel this. Where it's empty. Run. Yo. Not a number. Okay, eventually it gets not a number infinity. Oh, there's something wrong with this calculation then. Is it because I need to square? I need to square this. Do I need to do this? Okay, it doesn't seem like that. Okay, so we console logging A and B, 2 and 9, 14 and 5. I don't know how we managed to get 14. Oh, eventually it gets to 3 numbers. Oh, I see. So this was squaring the 14 earlier. Okay, let's see. So if we have 9 squared times 9 squared. Because that's the biggest number we can have, 9 squared times 9 squared, and it should be less than 1000, right? So, and then we can make another number, and then let's C equal to 8 math.floor 8 minus 10, and then we also do C times C. So in normal cases, A would be less than 10, and in some cases the A would be in the 8. I mean the previous sum could be in the hundreds. So if this is in the hundreds, then A would be, wait, hold on. Yeah, in this case A is still 14. Okay, if A is greater than 10, let's say equal to A. So we do the same thing, math floods, and then A minus 10. A divided by, actually no, this should, okay, C will always be like this, because if it's less than 10, it's just P0. But if A is greater than 10, after we're doing this math floor, we need to deduct A. Right, so 14 here. C will be 1, and we want A to be 4. If we want A to be 4, then A is equal to 8 mod 10. So now it should work. Accepted, yes. And now we submit both. Input is in the wait, hold on. Input is hundreds. What if we input hundreds? Well, if input is 100, it's just if we break it down to A, B, C, it's 1 times 10 times 0 times 0, and it should be 1. Okay, so if input is 100, we can console A, B, C. And ABC, the expected ABC is 100. Let's see. 1000. Oh, it's okay. It's greater than or equal to 10. Now run again. 001, 001, 01. Wait, hold on. The output should be. You see 3 number because I'm doing this 3 times. But if we return 0 times 0, 0 times 0, 1 times 1. Oh, because both of them are equal now. So if I move this to be here, if I move this to be here, then it should pass. Yes. Okay, so the previously didn't work because it technically should be working because now slow is equal to 1 and then fast is also equal to 1. However, while slow is not equal to fast, so this triggers this condition. So and it exits this while loop, so it returns false. So if we do the comparison at the end, then this will pass. Right. So now, if I submit this, if we submit this, immediately we get an infinite loop again. Use test case and run. Test case is true. True, false, true, true, false, true. But if I submit this, I get an infinite loop somewhere. Oh, the number could be, if they start number to be in the thousands, 10,000s, or millions, the number could be millions because the higher constraint is 2 to the power of 8. So for this one, we cannot restrain this into tar into only taking into account for hundreds, so we do taking account for more than hundreds. So in that case, less sum is equal to 0. So instead of doing C, we're gonna do a while A is greater than 0. And then we're gonna make a 10 value. 10 value is equal to A mod 10. Actually, we don't really need 10. Sum is equal to 8 mod 10. 8 mod 10. Yeah, 8 mod 10. Actually, having 10 is easier to calculate. Sum is equal to 10 times 10. Sum equal to sum plus 10 times 10. And then we can update the new 8 equal to the old 8 mod 10. So assuming that, then we just return sum. So we return sum plus b times b. Right, so assuming this number is like 999, right? So first A would be floods mod 10 and B would be 9. So this B is already taken care of. So A would be 999 while 999 is greater than or equal to 10. let temp equal to another 9 more 10, which is 9. Sun equal to 9 times 9. And then sun equal to sun plus 9 times 9. Right? And then A will equal to another 9 more 10. Shouldn't be more. Sun is equal to math.floor A minus 10. So another 9 minus 10. And floor of that would be 99. So A will be 99. While 99 is greater than 10. 10 equal to... So basically the n is like 9 times 9. 9 squared plus 9 squared plus 9 squared plus 9 squared. Right? So we have the first 9 squared, which is 9 plus 9. And then the second one would be the 9 more 10, which is B. So we already have B times B. So we have the second 9 squared. And then the third 9 squared, because 9 is greater than 10. But we still need one more. So plus A times A. So 99. We need one more now. So 99 is greater than 10. And 99 more 10 is 9. Sun equal to 9 times 9. Actually, let's not do it. So I can let sum equal to A times A right now. Okay, math float of 99 divided by 10 is 9. Now, because 9 is less than 10, so this breaks out. So that does the full calculation of 9 times 9 squared times 9 squared times 9 squared times 9 squared. So if this number is like even bigger than 9, it will still be 9 squared times 9 squared times 9 squared plus 9 squared plus 9 squared. So if I run this again, infinite loop. Okay, let's do 1 and 1. Okay, 23 and 1. Okay, 12 and 1. Hope that's the problem. Also log sum and B. Convert to string by word faster, yeah. Yeah, now you think about it, because initially I had two options. I can either do the math to separate out them, or I can just convert them to string to separate out them. Initially, I thought the number that they give us is always gonna be two numbers, 2 digits. So I thought that maybe math would be easier, but yeah, I think if the constraint here is number up to 2 to the power of 31, in that case converting to string might be easier. I think alright, because I'm doing all these calculations, so it's very easy to make a mistake. Okay, is array from for each element, you're gonna do x times x. Array dot floor num dot to string num dot to string becomes a string. Wait. If array from and then we supply a string. Array from floor. Flood. So it becomes FOO. Okay. It still turns into array. So array num to string. In this case, 1 2 should become 1 2. And then we do x equal to x times x. And then we just sum array from. Is there okay, 我就 return some array reduced. Previous value sum. And then current value x. Sum plus x. Right. Oh, do we need to put initial value? Initial value is 0. Initial value is 0. Return this. Okay, now it's fine. Omit. Oh my god, that was so easy! I don't think we should revert the number type because this is JavaScript. So, technically x here is a string, like string 1. But if you do string 1 times string 1 is actually equal to 1 times 1. This is a weird part of JavaScript. If you do this in other like strongly typed language, this will give you an error and say, okay, you cannot have a string times a string. But we can do this because this is loosely typed. So technically you have to do this like x you have to wrap it like integer or something. Integer. You wrap it with integer and then basically you convert that to integer. Wait. X dot to int or something like that. To int. And then times as to int. So in other languages you have to convert this. But JavaScript is weird, you know. TS じゃないのが TS じゃないよ。That's the whole cosine equal. Yeah, in this case we don't care about equal or not. Because the end result will always be a number. The end return is always a number, so we still, I mean, it's still a good idea to, if you want to make sure that your result is what you want to get, you do a equal, triple equal. Okay, so let's see. Yeah, I've never heard of this before from static. This is my first time using this array.flow. Iteratable array-like object. But you can also pass in string. And in which case it just turns into a iteratable array with each letters. So in this case, the inner loop they eventually create a infinite loop. And once we detect that infinite loop, that's why we use a fast and slow pointer. And once we detect that, we just exit out. Oh, look at that! You see? The solution is using math. In that case, I was very similar. I first divide the number by using a mod, but in that case they just keep dividing the number. They just keep dividing the number and then times that value, and then you do a math flood. Eventually, the flood will once the first letter is calculated in this sum, eventually the number will become 0. So 0 minus 10 will become 0. So this eventually will break out this while loop.やっぱり文字にするのは千度だったか。そうですよ。私は最初から数学と文字すると2つの選択があった。2つの選択が思った。だから私は最初数字の方をやっぱ日本語説明難しいや。That's why I initially tried to use the number because but I fucked up this part. But either case, they both work. You are genius. No. You are genius. Okay, Palindrome. Common challenge, Palindrome linked list. Given the head of singly linked list, write a method to check if the linked list is a palindrome or not. Your algorithm should use constant space and the input linked list should be in the original form once the algorithm is finished. The algorithm should have big O of n time complexity where the m is number of nodes in the linked list. Oh. They want to be n times. So you either have to go through this once or you go through like in a constant number of variations for this to be n1. I mean big O of n. Because in big O notations we don't care about constant values. So even if you loop this twice or loop this like 9 times, it will still be treated as big O of n. Just explaining what this notation thing is. Write the method to check if linked list is a palindrome or not. What is a palindrome? A palindrome is base sequence node that read the same backward as forwards. Oh. So this will be palindrome because 2, 2, 4, 4, 6. This is not because 2, 2, 4, 2, 6, 4. Okay. The first brute force that I think of is we're gonna traverse this through this list, and then we're gonna add this number all into a string. So in the end, it'll become 2, 4, 6, 4, 2, and then we do the regular calculate palindrome. But I have a feeling that this is not what that question is asking you for. The input is it's not easy. Because if you want to compare palindrome, you want to compare the first value with the last value. You compare the second value with the second last value. But this is a singly linked list. So you can only traverse from one value to the next value, but you don't know what the last value is. Strandify, yes, Strandify. Speaking of Strandify, there's a new agent. Leona is coming to Strinova, so I might play Strinova later today. I can do it in big O of n of 2n. New missions and the already finished the new missions, by the way. I was bored yesterday. I didn't stream, but I played some random games and then I finished all the events. I mean, I finished most missions, only like one left, so I didn't bother to do the last one. But I already finished all the events. So let me get water. So you know that the brute force is like this. Okay, hear me out. I'm gonna loop through this hole once until it hits the null, and we're gonna construct an array. So we're gonna construct an array, right? And then we're gonna loop through this again, and then the next time we are looping through this, we're gonna look at that array, and then we're gonna traverse the array from the back of the array, and then look at the number and see if they're the same. And until we hit the middle of the array, and they are still up to the middle of the array. If they all the same, then it's a palindrome. So that will be big O of 2n times time complexity, which is big O of n. And space complexity will be big O of also n. But so that will solve that problem, right? What I propose would find a palindrome for sure. However, I don't think this is what this question. I don't think this is what they want me to do. Got it. Especially this problem set is under the pattern of fast and slow pointer. Oh, you cannot construct both forward and backward in one loop. You cannot. Because this is a singly linked list. So you only know that the head, you don't know where the tail is. They don't give you the tail. Otherwise it'll be super easy. So yeah, how do you approach this with slow and fast pointer? Slow and fast pointer. Push it back, push top. No, this is a linked list. They specifically said this is a linked list. It's not like that they're giving you an array that contains all these elements. And in the array you can just grab the last element and then you grab the last element and then traverse the backwards. You cannot do that. This is a linked list. A linked list where they only give you the beginning node. And the beginning node only has one option. Which is you can either return this value, or you can get the next linked list. And you only in the beginning you only know one node, which is the head here. That's why you cannot traverse from the back of this linked list. You can traverse from back, however, if you what I said earlier, if you convert this into an array and then you traverse back. Forward plus val, backward is val plus backward. There's no backward. Look at the constructor. They only give you one head. They only give you one node. And within this node, the only two operations you can do is this.val returns the current value of the node, or this.next returns the next node. You cannot traverse backward. That's what a singly linked list does. Unless it's a doubly linked list, then they might have this.previous. But the question constraint specifically stated that this is a singly linked list. Forward and backward are variableness. Well, it's a variable name that you initialize, and the question provide you with initialize only forwards. It's also in this stack, yeah. Like I said, the initial I said the initial brute force is basically you don't need to well it's I suggest we use array, which is same as a stack. But I don't think this question is asking me to do it this way. Because if we're doing that solution, then it's no longer fast and slow pointer. So I can traverse I can traverse through this one time and push them into a stack. Right. I can even just push them stack from backwards. And then we traverse through this array again, and then look and then take out the values from the stack and then compare them. And that will be done. Yes, that's easy. That will be done. But in this has a space complexity of n. If you're using a stack, you have a space complexity of n. I believe this question wants you to do it in a space complexity of 1. Which is the problem here. I don't have a good solution to doing slow and fast pointer. Oh, wait a minute. Why is the... What was my... Was the chat showing on the screen? Okay, it's working. Okay, fast and slow pointer on this question. Fast and slow pointer, fast and slow pointer. 2, 6. Also, one more thing to know. The solution that you guys suggested will also not work. It will not work if this singularly linked list has a cycle. So there's a possibility that it will enter a cycle. Actually, you know what? Can it be... Yeah. Okay. Here. We cannot do that because your algorithm should use constant space. So big goal of n space time is not a valid strategy. And plus, we don't know whether this linked list contains a cycle or not. So if we're pushing them into a stack until we finish the linked list and then compare them again, if this linked list has a cycle, then we'll infinitely looping that cycle, which will create an infinite loop. So what you propose cannot work in this case. Because the question basically is saying you are not allowed to do that. I don't have a good idea on this. I don't have a good solution on this. As we know, a Palindrome linked list will have no value that reads the same backward or forwards. This means that if we divide the linked list into two halves, Oh my god! One of the things you can do in a linked list using a throw and fact pointer is to find the middle value. Oh, just chop it in half then. Oh my god! we just need to chop it in half. Oh my god. No, even we chop it in half. Even with chopping in half, we can only read the next value. So if the first half is start from the head, and the second half starts from from the middle. Then this is not looking for palindrome. Anyways, you know what? Let's chop it in half first, and then we'll figure out it afterward. Let's slow equal to heads, and then fast is equal to head. And what we want to do is while fast is not no, and fast on next is no, right? And fast is equal to fast dot next and dot next, and slow is equal to slow dot next. Well, we have slow dot next. If we store the first, puts half into a variable, but then that would not be a constant space time. So we cannot store the first half into a variable. Okay, but by the time fast hits no, slow will be at the middle. So this is how we found the middle value. You go to flute and you feel like crap. Oh, I'm sorry to hear that. Drink more water and it's on. Oh, you know what? In Asia, you probably seen that in anime before. In Asia, I said but I never had it before because I was poor. They give you candid usually candid. What's the name of Momo? Momo no eigo wa nan desu ka? Pearl? No, not pearl. Basically candied fruit. And then you eat the candied fruit. Momo. So, Momo. Momo no eigo wa nan desu ka? Kaze no peach. Oh, peach. Yeah, they give you candied peach, and then you eat that if you have a flute, or if you have a fever. 風邪とか体調が悪そうな時、時々桃缶食べるんじゃないですか。食べるんじゃないですか。アジアのところ、アジアの地域。いや、体調が悪くなったら、桃缶なんちゃって。Oh, and so they do that. They also have that in China. Is what I read recently from a video. But I never had that when I was a kid. I never had that, and they do that now. They do that now because in Asia they don't really eat. In Asia they don't they're not accustomed to eating candy foods. So there's less candy food in circulations in Asia's markets. So candy foods are, because less circulation, that means they're more expensive. So for people that are sick, they serve them candy food because it's treated as a little bit luxury, and also gives you the vitamins that you need, because you're sick, so you need more resources to fight the disease.数十年前くらいはそうだった。数十年前？は？そうですか。でもアニメの時は時々見られるんですよね。アニメの。Shouldn't the wild stop its cycle is detected? Yeah. We also can detect the cycle because we can do this. If slow is equal to fast, then we just return false. Actually, we don't need to return, we just break. You break it out, it will return false. So that's how we detect a cycle. You detect a cycle because the fast pointer is eventually gonna reach the slow pointer, and if they are the same, then you break out. Then it's a cycle. Candy food is yeah, that's true too. I have some candy food now, and if I get sick, I'm actually try that. But although nowadays, if you get sick and you don't have time to prepare, you can just order Uber Eats or DoorDash or whatever. Yeah, this is how we detect a cycle. Okay, so we found a middle. We found a middle point. Okay, we found a middle point. Good job. And now what do we do? If we can cheat, can we do like... If we can cheat, we can do slow dot next equal to slow. Actually no. Slow dot next dot previous is equal to slow. Can we cheat like this? Can we create a new thing? So we basically yeah, I think it doesn't work. Because the constructor only accepts 2 values. If we cheat, then we can store the slow to here, and then we can... So, and then we do while slow is not heads. Right. If slow okay, we found a middle value. If slow dot next is not equal to slow dot previous, that is not a parent zone. Yeah, constant space, yeah. Otherwise it will be easy, right? I was thinking, can we do this? Can we store this value here? Let's see. You told me no. This means if we divide the linked list into two halves, the node value of the first half forward direction will be similar to node value for the second half in the backward direction. Okay, backward direction. Oh my god. Yeah. I think Joel's flu is spreading to me. Joel is spreading fruit using Wi-Fi. Okay, so the problem is how do we read the second half from backwards? As we have been given a single linked list, we cannot move in the backward direction. See, we cannot move in the backward direction. To handle this, we will perform the following steps. We can use fast and slow pointer tools, map it similar to the middle of the linked list to find the middle node. This is what I've done. Once we have found the middle of the linked list, we will reverse the second half. Huh? We will reverse the second half. Well, do you reverse the second half? Are you sure space need to be constant? Yes. 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 Your algorithm should use constant space. This is what the question asks you. Your algorithm should use constant space. We will reverse the second half. Once we have found the middle, we will reverse the second half. How do you even reverse the second half? Then we will compare the first half with the reverse second half to see if the linked list represents a parent join. Finally, we will reverse the second half of the linked list again to revert it back and bring the linked list back to the original form. Huh. This is weird. So they're reversing by modifying the orders of linked lists in the second half, and they're not storing that into a variable. So that's how they use constant space, and then after they are done, they reversed it back to previous to because the question also asks you to. The question also asks you to keep the linked list to be the same. So they find this and then they do a slow and fast pointer, and then fast pointer is no. Well, then the slow. Then slow is in the middle. So reverse the second half. Oh, you see? You see? I was saying, oh, can I do a previous and then head next equal to previous equal to no, previous equal to head. Head equal to next to reverse the list. You know, in a real world, they will never ask you to do something like this. This is why I don't like all these brain teaser questions. You can copy the listener stack then and look comparative value. That's why I said in the beginning, and the question said no, you cannot do that. Because you need to use constant space time. It would have been very easy to use a stack. But they don't want you to use a stack. They don't want you to use a stack, that's a problem. Hey, good content, please play Exodia. I can play the Exodia. Yeah, time is all event. That's true. Regardless which one you go, it's always all event. But the space they want to be all of 1 or all of 0. So this is the first half. You start from head to 6 to slow. But the second one is you gonna this is where slow is, right? This is where slow is. And you do a slow previous is equal to no. And you update the head to be well, you update the head. That's crazy. You updating the head to be head is equal to next. And then you go to next. You go to next, and then head dot previous is equal to previous. So in the second half, you head dot previous equal to no. And then head dot next is equal to head. And then you move. And then head dot previous equal to previous. Oh, this is very confusing. This is already giving me a PSDD. Like this whole procedure is crazy. So after you traverse through this, you end up with head to be here. Head dot previous is no. Head down next is head. See, you don't call it heads. Update head down next equal to previous. Equal to no, previous equal to head equal to next. Follow the same procedure until you hit next. So if you follow this procedure, eventually head will become no. Will start at the end no. And you do head dot previous. And head dot previous, head dot previous, head dot previous. And then you compare the head and the second head. Yeah, this is crazy. This is crazy. So first you do then no, then true. Slow pointer while slow head, and then you move next. Oh, they are assuming that there's no cycle in this. Otherwise, they will have to do the other way. And then this stop reverse head. So left previous is equal to no, and then while head is not no, head on next. While head is not no, next is equal to head on next. After you reverse this, you return the reverse linked list. So that's where the head of second half. And then you copy the head of second half. Okay? You store this value, but this is store the head. Oh, I see. So you store the second half, right? You will think that this is a space complexity of n, but it's not. This space complexity of 1. Because what you are storing, this copy is actually just one node. This is only one node that you are storing, so it's still constant space-time. So while head is not null and the second half is not null, you see if these two value is equal or not. And then you go next. And then after you're done with all this, you reverse this copy. Because you reverse this copy because the head second half is going from the current node to the next node. Where shouldn't this be previous? From the current node to the next node. So by the end of this will be at the in the middle. This will be in the middle. But you want to reverse that. So now you reverse this. Reverse this again. These fields are such a pain just for space-time of 1. Yes. I know. Exactly, I know. I see like this part is annoying. So head is equal to this is the middle. This is the middle pointer right now. So next is equal to head on next. Next is the next head. And then head down next is equal to previous. And previous is head. This is where it gives you brain cancer. This far is more gives you brain cancer. Okay, queen next equal to next. So you store the next into a next, and then the real next will be the previous. Previous is null. And you store previous to the current head. And you store the head to the next, which is the previous next. So you initialize this is you create a new node, and then have the previous to be stored as the next. Yeah. This fucks up your brain. So I was thinking about, can I use the previous? Right. Exactly what they're doing, but they're doing it in the fucked up your brain. Fucked up your brain's way of doing that. So now instead of this, okay, we are going to write a function to reverse this. Reverse edge. Right, we're gonna create a previous equal to null, while head is not equal to head dot next is not equal to null. So we're gonna traverse through this thing, and then we're gonna create a next which is equal to head dot next, and then yeah, this gives me brain fucked. We'll create next equals to store the next. Yeah, we update the current head to be the previous. You know, we update the next to be previous, right? And then we update previous to be the current heads. And then we can update the current head to be the next. In the end, we returned after we return the heads, this head will be reverse order. Right, so let's reverse equal to reverse slow, because we want to reverse from the middle point. And then we have to make a copy of reverse is equal to reverse. So now while remember we updated the middle. So we start with slow is the middle. So we update the middle to have the previous point to null. So this so the initial heads will eventually also hit a null. So while head is not low, or reversed dot next is not null. If heads dot value is not equal to is not equal to reverse dot val. If they're not equal, then it's not a palindrome, so we return false. In the end, we found a palindrome, so we return true. And then after we're done with this, we have to reverse this copy. We reversed. Okay, and the way we revert that is we're gonna reverse the copy of reversed, right? In the end, so they will get back to the previous. The linked list will return back to the previous form, which is making this is making a brain fart. Oh, we are not okay. This we call it previous here. But we are not actually making. We are not making a new constructor. We are not making a new value in the constructor. We are just a placeholder called previous. So eventually, you want the next to point. You want the next to point to the previous. So we're just using the previous to hold the value before before. So after you return the head, so remember, like we are not storing previous into anything. So after you return the head will still be head on next, but the head on next is now is what this previous value is, even though we're not storing into the constructor. I know, it's a brain fucked. It's a brain fucking way of reversing this thing. Okay, so we have an issue here right now. Issue is we are running into an infinite loop, I think. A is the what? Oh yeah, you're right. And yes. Okay, submit. No. Okay, this is the value. Still return true. So we move here until we hit to the end. Fast on next fast. Fast. And then fast. That's 3. So slow and slow and slow. Slow be at 4. Slow is at 4. So you break it out, would be 4 to 2. Reverse that would be 2 to 4. So 2 and 2 is the same. 2 and 4 is not. So this should be false. Head of bell. Oh! I'm not reversing this. Head now is equal to head dot next. And then reversed is equal to reverse dot next. Okay. Run to again. Submit again. God damn it! I feel that I shouldn't be updating the head. If we reverse this, yeah, fuck up this reverse bar. Return previous. Oh. Eventually, previous will be the new head. Oh, cause we're doing the head here. Wait, head's next. Hold on. Head's next. And previous. I think I shouldn't be up in the head. Right, so previous is gonna know, while head is not know. Next equal to head, next. And next is equal to previous. Previous is equal to head. Head is equal to next. Where head is not know. One, two. 1, 2 is true, which is not true. One, two. 1, 2. Slow be is head, and then jump here. Slow be a 1. Reverse slow should be false. Oh, if we reverse slow, then the first half equal to no. Wait. Reverse slow. First half. Slow is at 1, so reverse will be 1. Oh, because I was doing reverse on next. Reverse next, so reverse is at 2. Reverse is at 2, so 2 dot next is no. So this immediately breaks. So this while loop is not even run, so it just returns true. Okay. Okay. That's the brain fuck that we're getting. I hope I don't get this kind of question in interview. Anyways, I'm gonna stop here. I will play some game later today. I will see you guys next time. Bye-bye. I'm interviewing for a job. Yes. Actually, no. I haven't even applied for a job. But I think I eventually will, because being a VTuber does not give you any money. I mean, you do get little like pity money from YouTube or Twitch, pity ad money from them, but it's like pity money. The amount doesn't even cover my electric bill. Right? It's that. Being a streamer, content creators, unless you have like millions of subscribers, then like you cannot even survive. You cannot even survive. I can survive because I have savings and I have other forms of income. But I try to make this work, but it doesn't working. So I guess I will eventually go back to work. So that's why I'm just chilling and doing these things. Anyways, bye-bye. 自知心当初有多么激励 着胸口就都冷冰冰。数一数身上几处淤青，还剩多少不是个说，证明我也曾经叛逆过，我也曾经离家出走。